This podcast is brought to you by Ironsight. The logistical complexity of oil and gas field operations can make it difficult to stay on top of who is doing what, where, and when. That's where Ironsight comes in. And so Ironsight connects E&Ps, midstream companies, and service providers so they can collaborate and coordinate with the field services and internal resources more efficiently. Ironsight was designed to support everything from fluid hauling and hotshots to maintenance and trades, making it one of the most versatile field operations and logistics management tools on the market. How do they do it? Well, the secret sauce is, regardless of what type of service, every single job you need done is going to follow the same core workflow. Somebody requests a job, it gets scheduled, the job gets executed, what gets done is documented, and it's reviewed, approved, and the data and the documentation gets sent wherever it needs to go kind of from there. So Ironsight has spent years perfecting their fit-for-purpose function, making their core workflow configurable to any field activity so that you can lower operating costs, reduce your risk, and be more effective across your entire field operation. So whether you work for an E&P, midstream company, or service provider, if you're managing field operations and logistics, you're going to want to take a look at Ironsight. They were also the EnergyTech Night Midland winner a few years back. They've also been on the podcast in the past, good friends of ours. So go check them out. Visit ironsight.app/DW to learn if your company is eligible for a free 3-month trial. It's Ironsight, SIGHT.app/DW. Click the link in the description and let them know that we sent you. What's up, guys? Welcome back to another episode of the Oil and Gas Startups Podcast. We're here with my guy, Alberto Diaz from VisualAIM. What's up, man?
Everything good, man. Yourself? Thanks for inviting us in.
Good. It's Friday, ready for the weekend. Gonna go out and hang out and relax a little bit. And so we first met, it's good to see you again. We first met when you were pitching at ETN. So EnergyTech Night Houston, right? You did the last one, right?
The last one was
a month ago, 2 months ago?
That is correct.
Yeah, okay. Which is cool because we're gearing up for the one in Denver. So by the time this goes out, Denver have already happened. But excited to finally take that on the road. We've only done one outside of Houston ever, which was in Midland like 2 years ago. And that was a blast. And so going back out to Denver, Midland, and OKC this year. So Alberto, you're from VisualAIM. What do you guys do?
So basically, the way that, to give you the quick story about how VisualAIM came to be, we're part of a larger company that's called TechCore. TechCore is an actual inspection services or NDT company. They do actual services for inspecting assets at the sites. And about 10 years ago or so, an idea came up to basically create a technology branch for that. Essentially develop a software that would capture the inspection information from these plants. And that's how the company got originated. I joined the company about 6 years ago when we basically had just one software product. And now we basically offer 3 main products. The first, which is our core product, is called the Mechanical Integrity Suite. That's your typical inspection data management system. It holds all of your inspection information and records to kind of predict out when you have to do your next inspections. And it also executes risk-based inspection based off of API 581, which is the main standard for risk-based analysis in the industry. After we developed that one, we kind of got sucked into creating the second platform because originally we tied the information from the mechanical integrity database with the plant drawings. So in any of these process facilities, you're always going to have primarily P&IDs, piping and instrumentation diagrams that basically tell you how the equipment is interconnected together. In the original development of the software, the information was tied to the asset representation on the drawing. So you basically had to create a drawing in order to have the asset record in the database and be able to store that data. The advantage of it was obviously the visual aspect of it. The difficulty with having that package together was the fact that you had to, create all of the drawings in order to have the equipment. The issue with that, when you go to small sites are okay, but when you go to a facility that has 500 or 1,000 P&IDs, it may take you 80 hours just to do one of the P&IDs. So it was extremely resource intensive in order to get that set up. So the natural progression for the platform was to basically break that into 2. Now we have 2 products. One is the Mechanical Integrity Suite, which holds that equipment inspection data. And separate to that, you have the IDP, which is the Intelligent Drawing Platform. That's basically designed to capture any sort of 2-dimensional drawing from the plant. Primarily P&IDs, because it's one of the main documents in the plant. But you've also got isometric drawings for inspection. You've got electrical schematics for things like junction boxes, loop diagrams, marshalling panels, and things of the sort. But we work primarily with P&IDs. And now that platform is basically able to process those 2-dimensional drawings and basically do one of 2 things. Either extract information from the diagrams or connect data into them. The easiest, or one of the most applicable use cases is to link it back to our mechanical integrity software. So you have that same concept as before. You click on a vessel inside of a PNID, and you get the inspection data from it as tied to the mechanical integrity record. And we've also got other projects where we just do data extraction from the drawings. So let's say that one of the clearest use cases from our perspective is whenever a company purchases an existing chemical facility. One of the things that they want to understand is, number one, are all of the assets at the plant being managed? So one use case that we do all the time is just to scrape the information off of the PNIDs, create an asset register, and compare that against either the CMMS system of the plant or the asset maintenance history of the site, just to make sure that all of the assets within the facility are actually being managed and or inspected. So just one of the examples. And then we transitioned over into sort of like a third type of product, which is basically for mobile applications and workflow management. It's applicable for basically anything that you have to fill out as far as a form goes, either for operator rounds, instrumentation calibration, and even pipeline construction management. That's something we started to do last year, where basically all of the inspectors that are working on a given project, as opposed to filling, let's say, an Excel spreadsheet every day at the end of the day in order to submit this over to their chief inspector, they basically just fill out the form in the tablet. And once you submit it from the field over to the workflow system, you can set up as many levels as you want so that QA/QC personnel or management reviews those forms prior to being finally approved. It requests your signature electronically, and that all falls into a database or a repository off of which dashboards are visualized. So it's basically a way to automate your status of the project on a daily basis without having somebody, creating reports on a daily basis. It just kind of feeds off of the database with all of the actual form records already there.
So is it safe to say that you guys are essentially like a project management / productivity tool for all people that are involved in maintaining a very complex type of plant?
That is correct, yes.
And then from that, you're able to generate the analytics and get the business intelligence and stuff and see where possibly you're either lacking in process, lacking in people. I'm sure you can determine that there's things that need to be maybe upgraded or things that need more attention. Is that pretty accurate?
That is all correct, yes.
Okay.
Mostly from the mechanical integrity perspective and operations. So we focus a lot on that, trying to make those processes more efficient and also being able to provide information more readily to both operations and maintenance personnel. One of the big problems in pretty much any facility that you go into, especially as you go into the older plants, interestingly, I don't think a new refinery has been built in the US since like the 70s or something like that. Expansion projects, but not new facilities. So you have the issue that you've got tons of records from these massive sites that have been evolving through document management and MOCs for the past 30 years or so. And one of the key issues in a lot of these plants is just finding the information. We've had certain projects where the entire deliverable was to process the drawings just so that individuals at the plant could search for a vessel name or a heat exchanger name, just so that they could understand on which PNID it's located. Because we've heard of cases where there's an operator or an inspector just trying to look for where a certain pressure instrument is located on the drawings, and they'll spend 2-3 days just to kind of trace down what PNID it belongs to. So even to that level, that's what we're trying to do. Basically, that's why the company is also called VisualAIM, is a way from a visual standpoint, which, that's where the drawings come into play because it's obviously visual. We're trying to make as much information available to these individuals, always tied to maintenance and operations or making those processes within those departments more efficient, essentially.
So it's essentially, are you guys kind of like almost creating digital twins so that you can conceptualize things? Is that accurate or no?
To a degree, it is. So it depends on what your definition is of a digital twin. When a lot of people think about digital twins, they always think back to a geometric model of a plant or a site, because a digital twin is nothing else than that. Like, you create the virtual representation of the entire facility, and then ideally you tie that with sources of information. So simple example, you have your digitized model of the plant. You've got a particular heat exchanger. That heat exchanger has a record in the CMMS system, which could be SAP or Maximo. So you want to be able to link it to that information to understand what work orders are, available in that system. You also have, for example, your data historian, which is typically going to be something like OSI Pi, which has all of your sensor data for pressures, temperatures of streams coming in and out of the exchanger. And then you might have a third system analogous to what I mentioned about our mechanical integrity suite, where you're going to have all of the inspection data, last inspection dates, and next inspection dates per API compliance. The idea behind the digital twin is to be able to have that representation online and link it to all of those external sources. So in terms of the question, do we provide a digital twin? To a degree, we don't necessarily create a geometric 3D model online, but we do try to, at least from a mechanical integrity perspective and the drawing perspective, have the relevant information available for those assets. And further down the road of that digital twin, although we don't provide geometric models, and when I say geometric models, a lot of the people who are perhaps listening to this might know what that already is, but basically, for a lot of existing plants, what we call the brownfield, there's not a lot of models out there that exist. For all of the greenfield facilities, anything that's developed today, typically you do have a geometric model that's part of the plan to begin with, along with the drawings of the plant. The engineering company or the EPC typically creates a geometric model of the site. For a lot of the brownfield facilities, which is what we mainly target, there's just no models available because they were not created at the time of the inception of the plant. So in order to get to some sort of model of the site, you're going to have to scan it somehow, which typically you use LiDAR technology in order to create a point cloud. And from that point cloud, you can use that for multiple things. And there's applications that will turn that point cloud into a mesh or into an actual geometric model. When I say geometric model, what I'm basically trying to say is that all of the entities within the rendering are understood. Like you can click on a piece of pipe or click on a piece of equipment and understand that that entire geometry is an asset representation. What we've been offering since last year to now, it's basically photogrammic 3D models. So it's not the same thing because you cannot, let's say, click on an overall asset and see the entire geometry of what it represents. But we do have basically like a walkthrough of the plant that looks from a photographic perspective exactly like how the plant is. So we have the cameras that enable us to do that. It creates the photogrammic model on the cloud, and then we're able to link that with our products like the intelligent drawings. Simplest example, once you have the model with all of the tagged equipment, you can click on any of those entities and it'll basically surface the drawing where that asset is represented. So again, it's a quick way for maintenance and operations personnel just to click on that piece of equipment and surface the PNID that it's related to or the inspection data that's related to that asset.
Is it kind of like a Google Street View?
It is exactly like a Google Street View, as a matter of
Gotcha.
fact. We use that analogy all the time from the PNIDs over to the 3D model, which is basically your map view versus street view that you would typically have inside of Google Maps, essentially.
Yeah. So as you imagine you're walking down Google Street and you could just click on a house, right? And imagine if you guys were like Zillow or something, you would pull up all the information. But using that as an analogy, you're clicking on certain portions of a facility and it pulls up the actual drawings. And now you can reference the drawings, probably technical manuals, other things that are associated with.
That's exactly correct. And specifically to PNIDs, that's basically a map of the facility. So in a very similar way, how you would see a road inside of Google Maps is the exact same thing when you have a piping route in the drawing. It's the exact same analogy to what you're saying.
So walk me through, because this is not a space that I understand extremely well. I can understand the concepts, but I've never really worked in it and never seen it firsthand necessarily. How is this? And I know that there are systems like the SAP and Wasmo that you've mentioned, particularly for whether it's planned maintenance or unplanned maintenance. How are these processes done now? Is it you're just scouring through these old data sources? You know, like you said, a lot of these facilities were built forever ago, 50 years ago now. And are you scouring that? Are you doing things? Are you taking that information and putting it into Excel? Like, walk me through, without you guys, how does that workflow work?
Sure. So it's ultimately going to depend on the facility and the company and how it's managed. To give you the most classical example, let's take first a small size site and then a larger size site. And it also depends, when I say the company, a lot of these corporations might have multiple chemical sites spread across the United States. And depending upon what the way that particular company manages their information, it might be different from one to another. So one of the situations that you have, and let's take a smaller chemical site, for example, that's slightly older chemical site. A lot of times they'll leave the chemical facilities to make their own decisions as far as how to manage the information, what software platforms to use, and ultimately how to run their day-to-day operations. To give you an example about this, we have certain customers that one of the main questions they have across their different sites, they sometimes cannot even understand or pull up inside of a dashboard or a report when their next inspections have to be executed across the enterprise. Because each of these sites have a different software system that's utilized, a different CMMS system that's utilized, and there's no synchronicity between those. So in those situations, when we go into those sites, we basically try to organize as much as possible the information that's available. Versus when you have certain corporations that try to do everything from an enterprise perspective, in those scenarios, you have the chemical sites that typically share the same software systems at the very least. Like when you talk about the CMMS system, which is for work order management, typically all of the sites are going to have the same platform, which makes it easier for them to understand, current open work order statuses and things of the sort. Same thing with the way that they handle the management of change in their documentation. A P&ID is basically an ever-changing document because across time, these sites will suffer from, capital expansion projects or demolitions of certain equipment. So as part of the upkeep of that documentation for process safety management requirements, you're always going to have to adapt that document to the latest version of how it's on the field. And typically, in order to manage that, the sites will also have a separate software system that's called an enterprise document manager. What that allows you to do is basically create a workflow so that, when an inspector in the field redlines a drawing and says, there's a new piece of equipment here, that goes to whomever the controller of that system is, and they'll go through an approval process to check out the latest version of that drawing, do the change, and then check it back into the system. And there's always a master one in there. Because when you start to, manage these massive businesses, it can very easily get lost, in somebody's network drive location. Like, hey, I have the latest copy here. So they try to keep everything in synchronicity with these document management systems. And the same thing with, all of the other applications that they manage at the plant. So long story short, the organization of the information at any particular site is ultimately going to depend upon the particular company and the particular chemical site. They might be very organized, have everything in digital format with the appropriate applications where you have the information, like the example of the CMMS system for work orders, an enterprise document manager for the documentation, and let's say perhaps a mechanical integrity system to manage your inspections. Where you might have another site that, or another situation where multiple sites have different CMMS systems. They might not have a document management system. All of the revisions might just be managed by a person that has an Excel sheet or multiple Excel sheets where they know what the status of each document is. And the same thing with the inspection information. That's actually very common where separate to the work order system, the asset management or manager of a particular site would basically manage their inspection schedule based off of an Excel spreadsheet. And in those situations, what you basically try to do is grab all of that information in the best way that you can and organize it or connect it together in the appropriate fashion. That's what we try to do from the mechanical integrity perspective, basically organize the information from those Excel sheets into the system to kind of give it a little bit of more robustness in the work processes of how the inspections are tracked and managed. And from the intelligent drawing platform perspective, just be able to basically keep those drawings up to date in a more organized fashion. And if you have multiple systems within your plant, link those systems with the P&IDs so that you can have the related information with those.
This podcast is brought to you by EnergyX. Are you tired of paying huge rates to the big cloud providers? Are you worried about being booted off a cloud platform if your company doesn't meet their ever-shifting standards? Ready to step up your data security and disaster recovery game? Well, ladies and gentlemen, your new cloud is ready. Introducing xCloud, the scalable, resilient computing cloud that is also actually affordable. It's high-performance compute for half the cost. HPC for HTC. xCloud from Red Team is opening a beta program for new cloud computing customers, and that means you, my friend. The xCloud is powered by the XMDC immersion-cooled modular data center from EnergyX. I've seen this data center in operation, and it is a total game changer. So if you want more information about the beta launch, go to the URL in the description. Type in promo code BETA, BETA, for 50% off of your first instance. And so the URL is going to be digitalwildcatters.com/EnergyX.
Great answer. So whenever I was in the Marines, I was in a maintenance platoon. And so I was fixing radio systems that were coming in. And then the last half of the time that I was in, I was on the supply side. So I was our liaison. So every time we needed new parts, I would have to go and look through all the different vendors and figure out, this one's a piece of shit. Don't use that one. Hey, this one's a better one. Do you guys touch into the supply side at all? I mean, I'm sure as you're going through inspections, you're realizing, this piece is not going to work. It's not up to specs or regulations or whatever it is. We need to go and replace that. Do you touch that at all, or do you interface with any of those kind of systems? Walk me through that.
So yes and no. A lot of the information that you're talking about with the vendor data would actually reside in these systems that are referred to as CMMSs, which are computerized maintenance management systems. Okay. Those are going to typically have your vendor data, your stores information. So when you issue a particular work order to fix an asset, that's where you're going to know what your vendors are or who they are. That system is separate to what we do with the mechanical integrity system. And when I refer to our mechanical integrity system, this can be any mechanical integrity database, which are typically referred to as inspection data management systems. And they do nothing more than that, basically schedule out when your inspections are due at the plant per API or PSM requirements. First off, the reason for having a separate system for mechanical integrity versus the work order management is the fact that these work order management systems or CMMS systems are not designed to hold all of the inspection information because a lot of the companies actually do schedule their inspections off of the CMMS system. The issue with that is that those softwares are not designed to hold the actual inspection data. Clearest example is when you do these inspections, you typically do ultrasonic thickness readings on the equipment. And when you do that, you typically try to record that information within the system so that 5 or 10 years down the road, when you do the next scheduled inspection from a time-based perspective, you can take those readings with the exact same points as 5 years ago, so you can trend out how the corrosion is looking. So that's part of the purpose of those systems, being able to track that data, which you cannot on the CMMS. Now, to your question about the vendors, we won't know what the precise or, which vendor you should use for certain activities, but there's always a part in our projects where we link back to that CMMS system to trigger typically one of two things, either the closing out of the work order, basically noting that an inspection was completed, or when you do an inspection, there's a chance that you might find something that we call a non-conformance. Non-conformance is, basically a third-party company or the company itself does an inspection. They find a particular issue with the asset that has to be fixed or addressed before putting the asset back into service. That'll usually trigger a non-conformance for you to, let's say, fix a particular nozzle on the asset because it already reached its minimum thickness requirement for the component. So when you issue that non-conformance, that would trigger a work order generation inside of the CMMS system to say, hey, yes, we need to order a new nozzle for this vessel and replace it. I don't know a lot about, vendors from this perspective, but you can take the analogy that, then because the work order is going to be linked to the overall asset that PM is related to, then you can kind of see what your vendors are for that. So from that perspective, that's how we interface with the information that would come or related to the vendor data that you're discussing. And that's from the mechanical integrity standpoint. We've had other projects just to kind of also talk about those CMMS implementations. We have had other projects where the companies are either migrating from CMMS system or for new facilities, creating their CMMS hierarchy from scratch. All of these CMMS systems typically follow a hierarchy or a way to describe functional locations of where the equipment are located. And it's typically in a parent-child relationship. Like, this is your plant, this is your process unit, this is your system, your asset, and the related components or equipment. For a lot of the projects that we do with the intelligent drawing platform, we'll actually create those hierarchies based off of the information that's on the PNIDs. So as mentioned before, the PNID kind of tells you how everything is interconnected. So what we're able to do from the diagram perspective is basically have the main pieces of equipment as the parents within the hierarchy, and then look at all of the lines that are connected to that asset and see downstream from that asset until you hit another major piece of equipment. Give me all of my filters, instruments, line names until I hit that next piece of equipment. And we'll basically grab all of those entities and make them as child positions of that overall vessel. So long story short, from the PNIDs, we're also able to derive those hierarchies that ultimately build the hierarchy inside of the CMMS systems. We still won't know or handle what vendors should be related to each of those assets, but we will, from the PNIDs, generate the entire asset hierarchy for these CMMS applications.
So one of the things that you said that I guess was kind of a light bulb moment for me was I'm thinking inspections, and I'm thinking just like visual inspections, walking through, hey, this looks good. But it sounds like from what you're describing, this is more like very, very like you're using some sort of instrumentation to like manage either thickness of, the metals, materials, managing corrosion, things like that. And so that makes sense to me now of why you would have these different systems, given you're probably generating a ridiculous amount of data, right? This is not just a simple checklist of like, oh, this is good, this is not, right?
That is correct. And ultimately it depends, because you can have just visual inspections of equipment, and you can just record keep that as the main report that was delivered for that particular visual inspection, let's say. But yes, when we refer to inspections in these plans from an API perspective, very typically you're also going to do some sort of thickness measurement on the equipment just to verify that the thickness of, let's say, the shell for a vessel, or a line, a particular piping circuit, you have basically sufficient material that's not below its minimum required thickness, depending upon the specifications of that asset. Yeah.
So you guys working specifically with, like, I know you mentioned like chemical plants. Are you working with like also like other refineries, things in downstream? Are you guys getting into the midstream space at all?
So yes, we work primarily with chemical companies and some refineries as well. We have had projects with one particular refinery where we basically enable them to get to their predictive analytics project about 2 years faster than their predicted time. So, and I mentioned this because a lot of the users that we have with the mechanical integrity software, those are more on the chemical facilities. On the refineries, this is one of the major projects that we have actually executed with a particular 300,000 barrel a day refinery, where they basically already had a funded project to implement a predictive analytics system. And the way that they were going about it, this is a scope of work that involved about 5,000 PNIDs, roughly speaking. And what they were attempting to do with the drawings is to, let's say you have a particular pump. You got to find the PNID that's associated with that pump. And then basically, based on a list of variables that they were interested in, like the inlet temperature or the outlet pressure, they would have to reference the drawing, see where the pump was located, see what the instruments that were measuring those process parameters were, and organize all of that information into an Excel sheet that they would then compare against the data channels from their data historian in order to understand, which of the instruments relate to the data streams from the historian to set up this predictive analytics system. That might sound as a mouthful, but basically it would take them about 2.5 years to organize all of that information, equipment variables per asset, across this 5,100 pieces of equipment. So using our tool with the intelligent drawings, we were able to cut that back to about 15 weeks. And essentially, the way that we achieved it was that in the same way we can create the hierarchy for the CMMS, we created a hierarchy that per equipment laid out the variables of interest, like the inlet temperature or outlet pressure. And from that, using the drawing as the tool, we extracted those instruments so that we would programmatically basically place those instrument tag names under the appropriate equipment variables, and then just do a massive gap analysis against their data historian system in order to deliver that. I just mentioned that story because, yes, we also work with refineries, but not so much on the inspection side, but more just delivering. This is basically an IT project where we used our tool to get them to where they needed to be 2 years in advance. And ultimately, our deliverable was a database for them. It wasn't the software itself. We just enabled them to get to their objective quicker. And that's it from the refining perspective and chemical perspective. We also work with midstream operators, both on the inspection side and also on the construction side as well. And now we're starting to delve into the calibration piece. So I think I mentioned a little bit of the pipeline construction, but basically with our tablet application and workflow manager, it enables their techs in the field to basically execute their inspections without Wi-Fi connection. Once they're back in range, they can submit their daily inspection reports or GPIN reports or coding reports, whatever those are, into the workflow system. A QA/QC individual makes sure that the form is properly filled in, checks the box, and basically that's what completes their process. And now we're also starting to do something very similar, but for instrumentation calibration. A lot of these midstream companies, not a lot of them, all midstream companies, I mean, they make their money with understanding how much material flows through their pipes. So every so often they have to basically go out and make sure that the instruments that are measuring pressures, flows, and temperatures and whatnot are measuring that appropriately, because you could be either overcharging your client or, the biggest issue, undercharging it. There might be more fluid running through that pipe than you think. So currently, a lot of these instrumentation calibrations are managed still in a sort of manual perspective. A work order gets executed from a CMMS system. An inspector goes out to the field, basically fills out an Excel spreadsheet with the information of how they found, basically as found data of the transmitter. And then they use a calibrator tool to make sure that it's measuring appropriately. And then you have like a tolerance factor. If it's within, 1.5 to 2% of error, it's good enough. If it's outside those parameters, you got to recalibrate the device. And all we're doing as part of this process is, instead of having those inspections being filled out manually, they're going to be filling them out through the tablet application that we have and submit it back to the work order system, so that it basically automatically closes out the work order and states how many hours the inspector worked, basically making the entire workflow more streamlined and not having technicians to go into the work order system to close out the work order. Basically, it's just a way to automate the process and save a lot of time as a result of it.
Are you guys going to do any work in upstream? Are you doing any work in upstream currently?
Not yet. We've had certain approximations with certain companies to see if we can do certain projects with them, but as of now, no, we haven't really done a lot in the upstream side. Mostly because they're not as drawing heavy. Let's say when you're looking at upstream, obviously you have your, and I'm not an expert in this by any means, but you first have obviously your geological studies. I mean, we have done no projects with that. We've had certain approximations with drilling companies just to see if there are any drawings of relevance within their processes in order to, kind of extract information or be of value. But no, we haven't executed any projects to date from the upstream side per se.
Yeah, it's particularly from, like, if you're looking at just like well sites, it's so much simpler and much easier to understand than, say an entire chemical facility or refinery or something, right? You could practically draw out all the piping on site within about 5 minutes usually. Now that's not every single site. Now there are some sites that are quite complicated, but the average well site is pretty simple to understand the flow and the things that you have there. Let's talk a little about you guys as a company. I know you said you've been there 6 years, and then I would say this tech portion is just a division of a much larger company. How many people do you guys have? Is everybody stateside? Like, walk me through the company a little bit.
Sure. So it's basically we're a sister company to a larger company that I mentioned before that has about 600 employees. We in total have about 15 employees, half of which are developers and the other half are engineers such as myself, basically. And part of us are stateside, and another part of a large group of the development team is actually sitting in Ecuador. We used to have an office down there at the inception of the company, and the employees that we had at that moment in time would just kind of remain working for the company remotely. So it's about half and half with those 15 people.
I usually go into everybody's background. Totally skipped over that. What is your background? Is you a chemical engineer or?
No, so I'm actually a mechanical engineer.
Okay.
I went to, as we were speaking before starting the podcast, I'm originally from Venezuela, and I came to Houston in the year 2011 just to go to school. Mm-hmm. And I came to U of H, enrolled into the mechanical engineering program, went through all of my years with that. And after I graduated, at the time I graduated, I was actually working with Caterpillar in their technical marketing offices here in Houston. And by that time, I couldn't land a full-time position with them because they wouldn't basically sponsor visas or anything like that. So I went back to school at U of H as well to do a master's in industrial engineering. And as I was in my last semester of that program, I actually, basically found this job with VisualAIM through a common friend that was working at the company at the time. And she told me that they were looking for additional engineers. I said, yeah, I'd be interested in interviewing with these individuals. And the person whom I interviewed with, is still my boss. So we're still there. pretty much.
Love it, man. So if anybody has any questions or if they want to reach out to you guys, what's the website? VisualAIM.com?
Yes, visualaim.com is the website. We're also very active in LinkedIn as well. You can just look up VisualAIM inside of the the searcher for LinkedIn, and we have as every website the submission form if you want to kind of have a 1 hour conversation with us to talk about the different solutions. We're there. We also have a couple of videos in YouTube as far as how we have delivered certain projects from a mechanical integrity standpoint and from the IDP as well. We don't have super high quality videos. It's just like a walkthrough of how everything works, but it'll give you a very good understanding as far as what it is that what we do and what we can deliver. So
awesome, man. Well, I really enjoyed it. It was good seeing you again.
Likewise. Thank you very much for your time, Colin.